What's going on, everybody? It's Mr. Gust, and I'm back in the physics classroom. Today we're discussing gravitational potential energy in a bit of a different way. So far we've been talking about things that are near the Earth's surface, things that have an acceleration due to gravity of 9.8 meters per second squared, things that are well within the Earth's gravitational field, not so much within their orbit, but seriously on the surface or near the surface of the Earth. Today we're going to discuss the universal gravitational potential energy. We're talking Mama G stuff. What happens when planets get involved, and why is the equation for you, Mama G, a little funky, wonky? Why is it negative? So we're going to discuss that today, and we're going to do so with this scenario, these two scenarios, kind of comparing and contrasting circular orbits and elliptical orbits. We, at one point, thought that all orbits were perfectly circular, and we learned through experimentation and through mathematics and calculus and data analysis that they are actually typically more elliptical than circular. And so because of that, we're going to examine these two things and figure out the types of energy that are present at different locations and how these energies change and why do they change. Is there work being done or not being done? Are these conservative forces? Are these outside forces on systems? So first of all, let's define our system. If I'm going to define the system for our purposes of this discussion, our system is going to be the planet, which is in orbit, and the sun. Like both of these, the sun and this planet, is going to be part of our system. So we're talking about UG between the two objects and the motion of this system. And typically the motion of the system is going to be the planet moving, and then the UG of the planet is going to be as it gets nearer or further from the star, the sun, that it is orbiting. Okay? So let's go ahead and look. Let's look right here. First things first, as I always do, I'm going to draw an FBD. I'm going to say at all of these locations there are forces acting inward. These are all the force of gravity. Let's use a capital G because we know it's not 9.8. It's different. So these are all FG. They're all pointed inward. And if I look at their radius, their radii, they are all the same radius. This path around the middle of that planet, they're all the same distance away from the middle of that sun. So when I'm thinking about ranking their energies, I'm going to start with ranking UG. And if I think about ranking UG, well, they're all the same distance away. There's all the same force of attraction between the sun or the star and the planet. So because they all experience the same force of attraction as it moves around, they're all going to experience the same amount of UG. I would say that the UG at A is equal to the UG at B, is equal to the UG at C, is equal to the UG at D. What we have to also be able to agree on is that this object, since it is in orbit, has a tangential speed. And it's always tangent to its path of motion. So because this is a circle, I'm going to see a speed moving in this tangential direction all the way around this circle. And that speed isn't changing because there is no outside force causing it to speed up. So if there's no outside force causing it to speed up, well, then I'm going to see that all of the kinetic energies are equal as well. There is no change in speed of the planet, which is the object that would have kinetic energy. It's moving at a constant speed. This is a kind of review of circular motion stuff, right? If this force is perpendicular, it will cause a change in direction, but not a change in speed. So a change in velocity, not a change in speed because of a change in direction. If I want to rank my total mechanical energies, I'd be taking the total UG plus the total kinetic energy at each spot and adding them together. Well, since they're the same at both locations, like the A's, B's, the C's, is D, because they're the same at both, I would say that the total mechanical energy at all of these is the same, where A equals B equals C, and that equals D. This is a completely conserved system. All of my kinetic energy stays the same. All of my potential energy stays the same, and therefore the total mechanical energy stays the same. We can think about that mathematically, but also there is no outside force. There's no second star near it pulling on it, slowing it down, no non-conservative forces. Okay? So we have this. And if we think about why there is no work done by FG, we can think about FG is exactly perpendicular to the velocity, and then in effect, that would be the distance that it covers. So no cosine of theta, or FD cosine theta equals 0 joules, right? Because there's a perpendicular force, we don't see a change in change in speed, only a change in direction, which is velocity. But let's go ahead and say now this path is elliptical. It's a little different. And what this means is that the UG is going to end up changing, right? Objects are going to get further or closer to the sun than they were in the initial example. So D is the closest, and then I've got C, and then A, and then B. As I get further and further away from the sun, as the radius increases, I know that the force on those planets decreases. So if I'm going to rank UG, I've got to rank them based on their location relative to that planet. So the one that is closest to the planet is, in fact, D. D has the most gravitational potential energy. The force is strongest there. If for some reason this thing were dropped, it would move the fastest. It would have the biggest conversion from UG to F. It is closest, there's the greatest force. And as I move further away, D is greater than C is greater than A, not equal to, greater than, which is greater than B. The planet furthest away is going to move the slowest and have the least potential energy out there. If I think about this now, the force is what causes things to move faster. It causes things to accelerate, sometimes changing just direction. But in an elliptical, or an ellipse, it causes it to change its speed as well. So if I think about the velocities, they are all tangent to the direction of motion. Tangent, 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 tangent. But I think about the force, and the force that's acting at point D is the largest, which means it's also moving the fastest. And then C is moving the second fastest, and then A is moving a little slower, and then at point B, I'm actually moving the slowest. So when I go to rank my kinetic energies, I know that the kinetic energy at D is greater than C, is greater than A, is greater than B. But hold the phone. What you're telling me is that as I move from D, first of all, before I'm getting ahead of myself, what you're telling me is that there are no outside forces. The only force that acts on this planet is gravity. Fg, which is really big there, and then Fg, which is smaller there, and then Fg over here, and then Fg over here. All I see is Fg, and that's a conservative force. It's within my system. It's not causing a change in mechanical energy. It's just causing a transformation. But at D, I have the largest Ke and the largest Ug. And then as I go to B, energy remains conserved, but it equals a smaller number. Let's try this. For purposes, let's call D 4. Let's say if D's kinetic energy has a value of 4, C is 3, A is 2, and B is 1. And we'll go same here. We'll rank them from biggest to smallest, 3, 2, 1. Now, these are not the actual values, but we're going to use them as placeholders to kind of help us rank things. So these are my ranks. Let's use these as numbers now. What you're basically saying is that the energy at D, kinetic energy at D plus UG, 4 plus 4, there is no work. There is no outside force. That work is 0. It's going to be equal to the kinetic energy plus the UG, these are capital G's, at B, because there's no outside force. If that's true, 4 plus 4 equals 1 plus 1. This doesn't add up, and I'm hoping you're at home going, Mr. Gustin, this is weird. I don't understand. There must be something I'm missing. And you are exactly right. There is something we're missing. This is where the universal gravitational potential energy equation is wonky. I think it's actually super, super cool. Because what I see is that the equation for gravitational potential energy takes a weird form. It's different than all of our physics equations thus far. It's negative. There's a negative value out front. So when you ask me, Mr. Gustin, how can 4 plus 4 equal 1 plus 1? Well, it's not actually 4 plus 4. It's 4 plus negative 4. And it's 1 plus negative 1. So I'm left with 0 equals 0. You see, as things get closer to the surface of the Earth, their UG gets more and more negative. The magnitude is very large, but it's negative. We go down, 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 down. And as I get closer to the Earth, I speed up, I speed up, I speed up. So the sum of those energies is still 0. It is just a matter of negative and positives getting larger. More kinetic energy, less UG. I'm getting smaller. Negative is less than 0. Negative energy means smaller than 0. 0 is this arbitrary number we have in the universe. 0, anything less than 0 in terms of scalar quantities is very, very small. Energy does not have a direction, so this negative means less than 0. UG, as it gets closer to the planet, is still decreasing. It's getting bigger in the negative portion of our number line. This is how this works. So, is this true? At D, it's moving the fastest, and it has the most UG? It actually has the least UG. Right? It's actually the smallest because it is the most negative. So we can flip this around where B has the most UG, and then it's A, and then it's C, and then it's D. Negatives make this thing work. Negatives make this thing work, okay? As in thinking about total mechanical energy, ask yourself again, is there an outside force? If the answer is no, then D equals C equals B equals A. They all have the same total mechanical energy. This is a little weird, but I want to make sure we're clear. UG being negative means it's less than 0. It is less than 0, whereas KEs are all positive. It's bigger than 0. All right? If you have questions, drop them in the comments. There may be questions. Comments, ask me in class, send me an email. Otherwise, see ya!